Dear all, welcome to this new episode of the CATIA Talk for construction. This time we are going to welcome the founder of SLIK Architecten, a Swiss-based architecture firm which is very innovative with CATIA. The presentation will focus on new building design with three parts: the use of component design methodology. The building consists in 4 floors with the same layout. Each apartment is a component by itself and adapts via parameters to the building level it will be exposed in. The transition from the design model, SLIK, the construction model, the woodworker, an error-free geometry with a shell that was erected faster than expected, and a model that can be adapted fast to modify details by the woodworker. This CATIA Talk will be held here in the post in our CATIA Buildings and Infrastructure community, but also in our YouTube channel and in our LinkedIn page. So don't hesitate to watch or re-watch the episode of CATIA Talk for Construction, and we wish you an excellent day and an excellent week.
That page is okay.
We are going. I remove.
So, hello everybody. My name is Stefan Lemmerzahl. I'm one of the partners of Slik Architects. We are a company based in Zurich, in Switzerland, and we are constructing mostly any kind of building, and we have a small group of people around myself that is using CATIA for construction. So today I will show you one project that we just finished. It's also in Switzerland. It's in Andermatt. That's a place close where the Gotthard tunnel is, if you might know it. So that's the passage if you go from north to south Switzerland. And it's on top of the tunnel, and then 1,400 meters. It's a ski resort, and in summer it's also a place where you can play golf or go hiking. At the moment, there's a really big development. You see here on this picture. It's started by one single company. It's called Orascom. It's a big company from Egypt. And Mr. Saviris, who's the head of this company, he invested in Andermatt already in 2006 or 7, quite a long time ago. And yeah, the picture here is more or less 1 or 2 years old. So you see there's lots of construction going on, and it should be finished by 2030 about. I will show you now a little bit how this project evolved before, because as you can see in the dates, we already started quite early with this in 2009, and it took quite some years until it was realized. In this time, it changed. So this was the competition entry that we submitted in 2009, and we won this one. But you have to imagine this competition was not a normal competition where you have just one winner. You could apply as an office for as much as 3 different plots in this really big development, and yeah, and then you were chosen or not. And we had the luck that we have been chosen for 3 projects at the same time. So this means we had many different houses at the same time. So then, after 1 year, there was a redesign already, because they had changed a little bit, how to say, the mix of the apartments. They had some more information about the underground, because there's something I forgot to tell. The buildings are not on the soil, but they are on a so-called podium, which is a 6-meter high construction out of concrete, where they put all the parkings in and technical spaces. So the spaces above the ground are all free of cars, as you see on these renderings. And then there was a big break. So for 10 years, we didn't hear anything from them. And I would say, yeah, it was a little bit COVID who kicked off a boom again for alpine apartments. And this is why now we have resumed the construction, because it was going quite slow from 2010 to 2020. Yeah, then we did another redesign. So this is now our 3rd design of the same building. But now it got realized, and if you compare the rendering to the result, it's quite close to what we have intended. This is, of course, one of the reasons that we managed to get so close to the rendering, is that we have used a really good process using CATIA. So the design was quite controlled. Let me show you a little bit how the construction worked. And what's important here is that we have a hybrid construction. This building is consisting to one part of a concrete socket and core, and then the apartments themselves are built out of a timber building. So you can see a little bit, that's the socket out of concrete. And this has one main reason. We are still in the mountains, so you can have a lot of snow, and you don't want to put any timber in the water. Huh? And then you see it better here. Okay, this is now a screenshot of the model. I reduced a lot of it so that to match the building construction process. You will see it in the next slide. But here you see quite well that CATIA, of course, was used to control both worlds. So we did all the concrete elements in CATIA, but also the wooden elements and how they meet each other. So we were always quite close to reality. You can really see that what we modeled is actually what has been built. And but in detail, it's quite a difference because the concrete process is still, at least in Switzerland, I don't know about the rest of the world, but here it's still quite traditional. So at the end of the day, your output is plans. So they want to have lots of plans, and then the engineer is using your plans to make all these all the steel inside and so on and so forth. So yeah, this is a really traditional process, while at the same time the wooden construction companies are really modern. They want to have 3D data, favorably like an IFC, and then they use your model to cut the wood and construct it. Yeah, this is how they work. So this is basically all prefabricated and then will be brought to site, even in our case, including the windows. They have been already inside of these elements, which added another couple of problems, of course, but it worked quite well. And also this could be, of course, found in our model. I mean, that's now a screenshot I did especially for today, but what you can see if I switch back and forth, that all the small holes, every recess, everything is one-to-one. Huh? So these guys, this is the wooden construction companies who did this model, they are really precise and really professional. Which also means on site, they don't use many plans. They have a computer where they see the 3D model, and if they are not sure how to mount stuff, they look in the model. Then, after the wooden construction is completely erected, they start with the technical installation. So first, what we have is on top of the wooden slabs that you see here, there's another concrete topping, which is important to make sure that the noise will not, so that you don't hear what the people above you and below you are doing. We use this zone also for the distribution of the electrical installations. And after the concrete topping, there comes the screed layer, where we put in the heating. What you also can see here is the mechanical air ventilation systems that are hidden in a big wall. Yeah, and it goes on. Even the details of the gypsum walls, in some cases, in the roof levels at least, have been derived from the 3D model too. So this was really like a straightforward process. The companies used our model to make their models, let's say. We also had some funny situations like this one. This is a fireplace, which is right under the main beam of the roof. And now you would say, yeah, that's not a good idea, but it works because the smoke goes out here, you see it here. So we go behind the beam, but it looks quite funny. And also the other planners have been using 3D, but of course not our system. So you see here there is some trial and error going on. So that's in the underground. Yeah, after everything is mounted and all technical installations are done, comes the finishes, the final touches, and you see now like the living room before and after. And this is how more or less the finished apartment looked like. I'll show you some more impressions. The left one is the same space, just turn the camera 180 degrees, while the picture is on one of the penthouse apartments, which are the nicest ones in the whole building. Now, meanwhile, on the outside, here we see the facade. This is quite early after, I think most floors are, no, the floors are all erected, but the roof is still missing. You can see the foils on top. So this is quite shortly after they finished with the wooden apartments. And then came comes the facade that we have designed actually. So the windows, as you've already seen, they have been part of these pre-constructed wood elements. But then we had the windows around, and for me this was a mock-up. So the total constructor called me to have a look at it, and they made it out of form and said, okay, form is correct, everything fine, you can go on. But then they just painted it. So using some ultra thin cement painting technique I've never seen before, but it's funny. So small is fake. But at the end of the day, if you had the plaster, it all looks as intended. I mean, we designed it in concrete, but yeah, you can also do the other way. And voila, that's the building today. It's finished now. It's already in use since the ski season. So they started to move in around Christmas. And the building is off the table from our point of view. Now let's have a look into the model a little bit more. So one aspect that I want to show today is our use of component-based design, because in this building we used it a lot. And maybe before I explain you the model structure, this is something I learned from Dassault a long time ago, that you always start with a skeleton. So it's still my way of doing it. I think you can find more modern ways today to do it, but so I'm stuck to this approach. So you start with a small skeleton where all the main information that's valid for the whole building can be found. It's basically, as you can see here, the levels, or the height information, of course, the shape of the building and the position of its core. And then all other elements are derived from this main skeleton. So you have sub-skeletons that are taking the main skeleton as an input and then add information depending on what you do. Only the staircase, which you can see here, which is a quite complex thing anyway, is completely derived always from the main skeleton. So if I change something here, which I actually did quite often, the whole staircase of the whole building will be adapted parametrically in a couple of minutes. Then for each floor has another skeleton, of course. And in this building, I split them into two because it seemed for me more easier to work with. So the first skeleton is the classical one, which hosts all the geometry decisions. And the second one is hosting all the component-based design parts, because there are quite a lot of them. You see it in the next slide. So what you see here, in the tree left, we have like the windows, the doors, and also here the apartments as component-based design parts. What's funny, if you go on the list view in the LOD tool, you find up to 95 elements, but on the left of the tree you see only 20. So this is because the apartments have nested component-based design parts in them. That's a thing I tried the first time, and it works amazingly well. So you can start with the apartments, and then as soon as you instantiate the apartments and they are in the model, they have all the information they need so you can instantiate the secondary elements inside of the apartment. So if you change them, you just delete an apartment, you update it, and then you reinstantiate it, and everything is again on its new position. So depending on the apartment and on the geometry, you have up to 10, 15, maybe even 20 CBDs per apartment. And here again is the doors. We have the floor coverings. We have some details of the lodgers. They're all are component-based design elements. Yeah, and okay, now you can ask, why do you do this? It's not because I like nested structures so much, but we had the problem that most apartments look the same, but under the hood they're not. So even if I have the same apartment on 4 floors on top of each other, there are some details that are different. And to control that, we started to use these small scripts that just check the level, and depending on the level, they make some small calculations. And here I can show you in the chimneys why we do this. So that's what you have already seen. That's this chimney in the living room. But under the hood, depending on where you are, we have now on the second floor 2 chimneys, and you have 3 in the 3rd floor and 4 on the 4th floor. And this has to be taken care of in the model somewhere. And here the approach helped pretty much. We also had in mind that the apartments that have been solved the buyers could have some modification wishes. But actually, it was quite funny. They didn't change much, basically nothing, only some surfaces. So our geometry didn't change in the apartments at all. So we didn't need this, but we could, with this component-based apartment approach, we could also, in theory, like change a wall or add a new one in one apartment without changing the other ones. So another thing, we didn't actually model the chimneys, because this is in Switzerland I'd say it's quite high tech, because don't forget we are in a wooden building. So wooden construction and fire don't match so well. So there was one company who was responsible for all this chimney stuff. They took also the guarantee that nothing will burn down. And we only controlled the recesses so that they have the space to pass. But this was then done in our model, of course. And if you look now in the wooden construction model from top down, you see now that like these are two apartments back to back, that we have these growing recesses for each floor. So there's another place for another chimney. Speaking about this wooden construction or production model, how I call it, that was also interesting, because the exchange, as I already think I stated, was taking part using IFC. But if we model as architects, we of course want to have a model where we see everything that's interesting to us. So it's rather detailed. So all elements that need to be produced can be found in here. But that's not what the wooden construction company wants to see. They wanted a quite reduced model like this one. So here they wanted basically for the windows, they were not interested in the details of the windows, because some other company is bringing them. They're not interested in the details of the doors neither. They just want to know the recesses. And because of, I think, the nature of IFC, they want to have them as positive volumes so that they can add them as voids in their software. And this was something also it was kind of a challenge, because we didn't want to model everything twice. So what we did is we had the two worlds in each part that was important for the wooden construction. So there was like a IFC volume and the architectural volume, which mostly consists of many different layers, and then the simplified version for the wooden construction. And then we could just switch in the model to architect's view or IFC view to export it, and this worked quite well. Yeah, and then if the wooden construction, like the IFC was imported to the construction software, obviously, and here you see now they added lots of details. So how the timber structure itself works, and then they also added already the electrical project and some HVAC details. So that's everything in here, and then you can just put it on a robot and pre-assemble the walls and slabs, and then bring them to Andermatt. Yeah, outlook. So what did we learn? What is the next step? I think because this building we started, as I said, in 2010 or 11. We used more or less heavily the CBD features of CATIA, but not yet the visual scripting, because at this time it was too new for me. So, but now we have, as I already said, we have more houses in Andermatt. The second one is actually to be finished this December, but we didn't use CATIA for it because like my CATIA team was already occupied with the other one. So another team took the challenge, and now the third building that's to be started in 2025, so next year, we use CATIA again, but only for the facade at the moment, which is a little bit complicated. So you see this is our next building. We start construction soon. And it is a wooden facade, which is using natural wood, but with a pattern that's that's like not added, but carved out using a CNC machine. And to control this pattern, which was heavily discussed with the client and also with the local architect, how to say, the local communal board that like controls the quality of the design. And they wanted really to know how do we control this pattern, what is the idea behind it, blah, blah, blah. So we had to bring them a lot of options. And it was done using a script, so which had as an input only like a surface and then some points that I could use to move around. They controlled where the patterns go more like wide or small. And this is an example output out of the script. So you have to be aware that there are really many of them. So there are thousands of those parts that are generated like this. So I think that's one of the strong points of CATIA, that it can control that without crashing. And yeah, then we could already transfer this to a company to test if the process works well. And yeah, it works like intended. So here you have a sample of a small patch of the facade. And we showed this already also to the client and to everybody, and we are quite happy, and it will be constructed like this. So yeah, thank you so much for listening. This was a fast forward. And maybe in 2 years again, I can show you how the third building worked. Thank you.